web servers, machines that need resilience, something you can trust. There are many companies who use and contribute to open source technology. And they do that because at the end it costs less, or it is more efficient, or it facilitates the use of cutting-edge technology if it's not in your core business. So for instance, there are many startups now who use open source databases, open source servers, just because they don't sell databases, they don't sell servers, but they use it, and they need very good technology. So they can contribute in this way, not without exchanging money. And their developers really love it. So, because, well, they form new communities, they can meet novel people outside of the company, and they think that it is a good way to create new technology. So, of course, I won't enter in a philosophical debate. I don't really like that. I'm very pragmatic here. When we decided to create Gephi as an open source project, we had two main reasons. The first one, it was because we received public fundings from the beginning. And so, as we receive fundings from the state, we consider that it is a public good, and so we should publish it in open source. The second one is very pragmatic. Most of the other softwares for visualizing networks are still open source. So there are quite a few which are proprietary, but for research, it's a real problem. I mean, you will compute some statistics using code that you can't review. If there are some bugs you don't know, you can check. So, as long as we know softwares have bugs and they evolve and it's quite difficult to make something good, well, it's easier for us to get trusted, especially when you are newcomers. You are just students, you create something, okay. And it's also much more easier for communication. I mean, if you create open source project, people will try it for free, will talk about it. Maybe they will start to help their colleagues to get into the software, and so it can spread very fast. So it is also a way to get known much more faster. It is also a way to create a barrier to entry for newcomers in this area. For instance, what's the point in creating a new project much more advanced than Gephi? It will cost millions. It will cost thousands of hours of development. So instead, it's easier to get the code and contribute. So it is also a way here to get into a market. So we have to think about open source as strategy. I mean, you have different kinds of licensing, some very restrictive license when you are obliged to reveal your code if you integrate open source code. So for instance, a GNU GPL license. When you start to use part of this code, all of your code should be in GPL and should be released. There are also less restrictive technology, much for license, much for the industry. For instance, MIT license. You just get the code. Okay, you can integrate it whatever you want. And that's all. You just cite the author. Cool. And there are also some in between. So for instance, in Gephi, we use two licenses. The first one is the GPL, for people who want to create free software. And we also provide the CDDL license, which is a license created by Oracle at the beginning of Java. So it's kind of a trade-off, because you can integrate the code, it is not viral, the rest of your project doesn't change, you don't have to release it, but if you change the files of Gephi, you should release those files. And so the improvement you make come back to the community. And it is something very important. It also allows companies to use it and integrate in their business. So we have many benefits in contributing to open source technology. For my case, for instance, it helped me to meet many people, to have the opportunity to travel, to get known for what we've done, and to have good opportunities. For instance, my PhD. I have very good topic. I love the place and the people where I work with, and it's just happened because of Gephi. I mean, I started another PhD because before this one, and it started very badly. Not a very good configuration between the different partners from the research and the industry. So after 6 months, I decided, no, it's going nowhere. I stopped this PhD, and I get no job. So I just called a researcher I know, told me about the situation, and okay, we'll discuss a bit. And he already knew Gephi, and we had some beers before. So, well, we find easily a way. Okay, you can work with in my team, and 2 weeks later, I had another PhD. Great. Just because maybe, okay, he trusted me as a good worker, and he already knew the good work we have done with Gephi. So, okay, it's a matter of trust here. And for the other people who contribute to Gephi, well, when we started at the beginning, we really wanted to get our hands dirty in a real world project. And so it was a way to create something useful, not any other toy project from the university, which lasts 2 months, and then you trash it. So something useful for the other people. And it was a good way also to learn the technology, to get used to discover the real problems. So we regularly created some code, trash it, write it again, a little better this time. And as soon as it evolved, some of the developers became real experts in this area. And finally, so you have the main developer who get hired at LinkedIn. Very easily, he get contacted for that. We had other developers who get hired. For instance, there was one at Amazon working on statistical properties of their large networks they have inside. Another one who recently got hired at Facebook. Another one who is also at Google. And I mean, we don't sell any product. It's not our job. So what we do instead is try to promote the people who contribute to the project. It's a matter of value. I mean, the project by itself, even if you don't make any money, you don't exchange money, you still create an economical value if people use it and if it's more useful for their job, if they can work faster, much faster. And as soon as they recognize it, they also realize that the project is valuable because of the people who contribute to it. Because there are people who get skilled, people who can understand the needs, people who can talk. So this is our strategy at Gephi. We try to put the value to the people who contribute so that they can get paid at the end the way they want. Okay, they want to do research. We can promote them. They want to work in the industry. We have contacts. very good contacts in many companies. Well, it all depends on what you want. So, well, let's talk a bit more now about today. More practical things about publishing results on Gephi. Some good stuff about dynamic network analysis, and especially if you want to code in Gephi. Well, you can create plugins. You can use Gephi as a Java library. You can create an entire another software from the Gephi platform. It will be up to you. Yeah, just to finish about how it works. We have created an open source and a non-profit organization called the Gephi Consortium. When we try to get partners around the table and discuss about the future of this technology to identify what are the real pains, the real need, where we should go forward. And we start to have some very good contacts in a company, for instance, who use Gephi intensely, like Linfluence, who do a social media analysis, Quid for market research. Well, also Google funds us each year through the Google Summer of Code program, and we have also some contacts with universities like UTC, where I'm from, or Sciences Po for sociology. Well, some project at Stanford, and some companies, for instance, Neo4j Graph Database. They serve many companies who have to deal with networks and have to query them in real time for their customers. So these partners, okay, we can partner by, okay, get recognized by, okay, you are useful for me, you can support me, we exchange our logos, that's good. And some of them also make some donation for our activities to continue, for instance, to pay the servers, or to go to conference, or to pay some developers some time. So it start to be good. So if you start to use it, Gephi for real, I mean, it seems very useful for what you do. Just drop me an email, and if you want to support us for free or anything else, well, I will be really, really happy. It's a really good way for us to show that we are useful for real people. So that's good. Okay, so let's switch about something else. So in Gephi, there are different ways to publish a result. I mean, you could just create an image and insert it in a report or anything else. So this is what we've seen. If you go to preview and you export it in either PDF, PNG, SVG, it's one way to do that. Well, you could also take a snapshot inside Gephi. So you see here, I could click on it and export exactly what I see in this window. So sometimes it's useful. But if you want to export on the web and to make the visualization interactive for your users, which is very, very good to promote what you do, we have some plugins for that. One of the plugins is called the Sea-Dragon plugin. So on the Gephi website, on plugins, you will see the list of every plugin you can get in Gephi. So by using this plugin, it will generate many image tiles, and you can export it directly on the web. I try to find, it should be an example. Not this one. So you will export directly the HTML code to embed on a page, and so you'll be able to zoom. So if you have a very, very large network, it's very easy for the people to start to explore. It's a good way. There is also another way to get your graph on the web. It is using another technology, which is called Sigma.js. Here, this is a JavaScript technology that is able to render a graph exported from Gephi in the GEXF file format, which is our format to store and exchange graph data. So it is able to load it directly and to render very efficiently on a web page. So up to a couple of thousands of nodes. Not that much because it's still in the browser and it's using JavaScript. But for instance, okay, I can easily zoom in. Zoom out. I can compute also some layout algorithm if you have not done it before in Gephi. And it has also some very nice ways to interact with the network. So here we'll see only, we can't really see here, but all the edges become gray, but the direct connections of Gavroche. Or another one where you only see a subgraph. So it is also a good way to publish results on the web. People really like it and start to use this technology. And also you could just export a PDF and publish it on the Microsoft platform called Zoomit. So it's also C-Dragon technology, and it's initially made for rendering very large images. But, well, for instance, can be good to publish very large graph. So here, a graph of music. Okay, so until now, we've mostly seen static networks. I mean, networks that don't evolve over time. In Gephi, you can use dynamic networks, dynamic network analysis. We recently integrated a timeline, for instance, and some abilities to compute statistics over time. So this is what I will talk a bit more now. So usually, you have different ways to model dynamic networks. I mean, you could just take a snapshot of a network over time, and so you have different slices, different snapshots of your network. This is how most of the softwares implement temporal network, because it's really difficult to get this kind of data. And until recently, we only worked with static networks. So you will find, for instance, this software, Sonia, where you have the notion of snapshots, and you will compute the metric over, for instance, to study the evolution of B2ness centrality or average degree over time. In Gephi, we don't have the notion of snapshots. It's very restrictive. Instead, we created a more generic way to to model dynamic networks that we called lifetime. I mean, every node, edge, and attributes have a life duration, start and edge during time. They can appear and disappear, reappear later in the network. So, for instance, for the node company A, it can exist from this date to this date. And after that, maybe we don't observe anything, or we don't have data, or it really disappeared. And there are some people who also appear at specific observation periods. So what we will visualize in Gephi is the network that we can observe during a time interval. For every node or edge that appear during a period, they will be displayed. And for instance, the node A will be displayed during this time interval. The node C also, even if it starts here, not the node D, not the node B, not this arc. This arc, yes, we'll see it. So it may have very good so by using this time interval, you may want to make it move during time and see how it evolves. So we have the concept of sliding window, and when we compute statistics on the network, you will select what is the size of the time window and what is a step to compute the next statistic. So this is a way we can have dynamic statistics. Just to talk a bit more about how it is made in Gephi. So you know that Gephi is made in Java. We use the NetBeans platform on top of it. It is all the plumbing that help us to manage the windows, and also a modular approach to code. So for instance, we'll create Gephi APIs. You will have an API to access graph data. You will have an API to compute statistics. You will have an API to create partitions. You will have an API to work with a preview. So everything you have in the user interface can be also called with some code. And on top of that, you can create different plugins that will use the different Gephi APIs. So if you want to create a new layout, you just create a new class that will use the Graph API, and you make it extend the Layout API, and that's it. So as Gephi is a standalone application, you can also get part of the source code that is called the Gephi toolkit. It is Gephi without the user interface, compiled as a jar library, so you can integrate in your own Java program and use it in a server, for instance. Just script it. It works. Just to wonder, do you use NetBeans? Do you know what it is? Okay, good. So yes, that's what I talked about. So on top of NetBeans, we'll have, for instance, Layout API, Graph API, Filters API, and plugins that we'll use. There's different APIs. So this is also a way we are able to maintain and extend our code, which is roughly about 200,000 lines of code. Oh, it's Java, so it is expensive, very fast, but hard to maintain. We are very, very few developers. I mean, there are 2 main contributors in Gephi, and roughly a dozen contributors sometime. Most of the people are mostly interested to create new plugins because, well, they want to work for their own question, and sometimes they want to publish it so that they can get feedback from the community. So for the dynamic, there is also a dynamic API where we will manage the network state and various events. So it is accessible to browse the network through a timeline component to get the subgraph. And using this API, so we'll be able to get set the current visible interval, get what is also the time format. You know, that is always a mess. So we support date, double, dead time. And to compute dynamic statistics, so we'll select the size of the time window, progress step, and currently you will only be able to compute the evolution of the number of nodes, number of edges, the evolution of the average degree, or the degree of each node, and the evolution of the clustering coefficient. But it's really easy to extend. And you will play with the timeline. So in the timeline, you have the timeline here. Here you have the time period you are currently you currently visualize. You can play the evolution of the network, and you can also set some charts on the background to see, for instance, the evolution of the number of nodes and figure out when it is interesting to look at, when something happened. And you can also create animations. So currently you can't export videos directly from Gephi, but it's in progress. And you can have different ways to create animation. I mean, if you want to see the evolution of this time period over time, you will make moves 2 bounds. But if you want only to see the cumulative network over time, you will just expand, for instance, 1 bound. And for the various, if you have some dynamic attribute, so for instance, you have the evolution of the degree of a node over time, you can visualize it in the data laboratory. So, and see maybe if there are some particular period where the degree changes, and you'll be able to see where the node exists in the network and when it doesn't exist. So there are also shortcuts to to try to understand what's going on. And of course, Gephi will update colors and size over time. If you, for instance, you map the degree of a node to the colors, it will change accordingly. It was very difficult to implement because it has to be efficient. So, how to get dynamic data in Gephi? Currently, you have different ways to do that. The most straightforward one is to get an Excel spreadsheet. In the data laboratory, you can load a list of nodes and a list of edges with the different attributes. If you add just a start and end column, okay, Gephi will understand that it is dynamic. Or you could also connect Gephi to a database. And if you have a node table and an edge table with also the start and end columns, that will be taken into account. You could also just store dynamic data in the GXF format. But I will see if I have some time to dig a bit more about it. You can store many networks with this file format. And you can also play with graph streaming. So live events that you can visualize. I will skip it now. But I want to show you something. Well, by talking about streaming, what the video you see yesterday is using this plugin. And in by using it, Gephi can receive a stream of events. Add node, change node, delete node, same for edges, all expressed in JSON format. And you can connect two Gephis, a master, a slave, and see the changes in a workspace from the other. You could also work with two workspaces and see the changes in real time. I will show you some videos. For instance, so somebody created a plugin in Gephi to monitor the activity of your browser and create the web graph accordingly. Of course, it's a very small graph, but it's very nice to see the evolution of your navigation. So here it is a HTTP graph plugin, so you can download it and try it yourself. So if you want to teach what is a crawler, maybe it will be a nice example for people who are not used to web technology to see, okay, what happened when you navigate, when you go across various links. Could be nice for teaching. Okay, that's it. I have another example. Made from one of my students at the university. So he uses two computers, a crawler and a Gephi instance. And the crawler will send the events to, well, two Gephi instances, by the way. Yes? So you can start to imagine what kind of applications you can make. We monitoring the evolution of a network in real time. Other examples. This one is a contact face-to-face contact network in a school in France. some researchers in Marseille had this technology, RFID technology. They put it on you and they monitor with who you are talking, or more generally, where you are close to. And so you have the evolution during one day. Each cycle is a different classroom, and at some points you have lunch, you have breaks. For instance, now. And it is also a fast way to get an overview of what's going on, the different phases of the day. At the end, this study may help to understand, for instance, who are the students who have more contacts and maybe who could spread the flu. Imagine if your child get ill, they go to school, what may happen if this child tends to have many contacts? Maybe you should let him at home, but well, if it doesn't make so much contact, what would happen? What would be the consequences? Well, this is some kind of questions that researchers try to answer about the epidemic in human contact. Okay, enough video. Let's see what's going on in Gephi. So I will load another face-to-face contact network collected during a research conference. So hypertext 2009. So let's try to lay out initially. It's very dense. Almost everybody seems connected to everybody. Something not very good. So let's see what we can do with the timeline. I know that the date time, well, the time format is date. So I have 2 days and a half. Starting from June of the 28th to the 1st of July. I can filter my view to see only what's going on during the first day, for instance. And I can drag to see if there are some changes, but this network is always very dense. So I could also reduce the time frame. Okay, so I see that sometimes there are many connections, sometimes very few. So let's try to compute some statistics. So on the right, I have this dynamic statistics available. And so for instance, I want to know where do I have the most connections. For instance, for every hour, I want to know the number of edges. So I get some results, but I'm not really interested in this visual. I want it in the timeline. And here I will select edge count. Start to be much more interesting because I can know, for instance, see only what's going on during this day. So of course in this data you have 2 days and a half, so people don't usually see each other during night, or otherwise maybe you can see. Why do these people are connected at this time? Some outliers also. And to see an animation, how it evolves, we can set, for instance, the step to move this way. And if you think that it might be useful, we can also run a layout. Okay. So you can see you can get a very fast overview of what's going on during time. Of course, there are some difficulties to understand what's going on and to track the trajectories of individuals and the evolution of groups. So it is still very experimental. So until now, no software implemented this timeline, this technology, and we may certainly improve it over time as researchers find novel ways to visualize dynamic networks. This is a very active area of research. Maybe we could use the X or Y axis to plot the evolution chronograms. Maybe we could use specific layouts that will take the evolution of a network into account and try to fix the older elements. Maybe we should have 2 networks when you want to compare 2 snapshots to see the differences. Or maybe we should still stick in one image and have some signs, some glyphs about, okay, the trajectories of different nodes. Apparently, it really depends on the analysis and the interface. Well, we are still in the making of. We still don't know what will be the best to implement. So currently in Gephi, you have this ability to handle dynamic network. And voila. I hope it will be helpful for you. Okay, we've seen it. Yeah, so we have seen, so for instance, researchers study the evolution of the blogosphere. Some others study contact networks. Others do document mining over time. Some people try to visualize Twitter or make real-time crawling. And some others start to try to understand how source code evolves over time. I mean, you can also model source code as a network with a method, calling other methods, or classes depending on other classes. So you may be able to grasp what's going on in your source code. Yeah. Okay. That's good for dynamics. So let's talk a bit more now about how to code with Gephi. So it's really easy to get information on how to start coding Gephi. If you go to the website on the developers part, you will find some information about how to get your head into Gephi with a developer introduction. And you will have references to the various APIs. So it is a Java doc. So for instance, if I want to know what's going on with the Graph API, what are the methods, I can directly get, okay, the different attributes and different values. What can I get? And more importantly, so we host our code on GitHub. Very easy to get. And you will need NetBeans platform to code inside Gephi. If you want to code some plugins, we have also documentation for that. Here there is what we call the plugin bootcamp, which is a code repository with various examples on how to implement a new layout, a new visualization. So for instance, grid layouts, new filters, how to get only top nodes, implementing a search, connecting to the database, have other ways to render the elements. So just get this code, see how it is made, and you can start very fast. You will also find useful information on the wiki. So there is many information, but for the developers, there is a plugins portal where you will find every information about how to check out the code, build Gephi, maybe run Gephi also in Eclipse, and also programming. All of these tutorials. So how to start a plugin in Gephi in 5 minutes. Well, I don't really have time to show you, but it's quite easy. I mean, Gephi plugin is just another NetBeans module with dependencies to Gephi APIs, and by extending the right class, your plugin will be automatically integrated. For instance, the new layout in the layout list or new statistics. All awesome stuff that you have only to focus on what you want to do. For instance, if you want to write a new statistic, you will have, of course, to set some dependencies about, okay, statistics API, how to get information from the Graph API. You will create, well, I mean, there is only 2 classes. One to interact with regular Gephi, and one to focus about what you do inside the statistics. So also one if you want to have some user interface, specific user interface. It's up to you. So this is a sample of a statistic. Well, if you want to do, your code will be exactly here. So you don't have so much sugar to add to make it work. So yeah, there won't be so much here. No, it's not what I wanted. Well, yeah, so for instance, if you want to implement a new statistics, you will use this statistics API. What you need is just to get the proper graph that is currently displayed. So this is provided by the interface. You will add very easily support from the progress of the interface, and you'll have some facilities to create HTML report. So, and images you can embed in your papers. So I have not so much to say about it. I mean, it's really get the code, try something, use the wiki with the tutorials, and if you have some questions, don't hesitate also to send us an email. I mean, we mostly use the forum for user question, and for developers, you can use the mailing list. There is a Gephi plugin mailing list. And if you create a plugin, you can also easily publish it to make it available for other Gephi users. I mean, if you want to have 5,000 users ready to try your plugin, you can package your plugin in an ABM, just a jar, with specific information for NetBeans, and go to our platform, get login, and start to upload your plugin. We will review it, try to see if everything is alright and it can run in various platforms. It will become available. So for instance, for the graph streaming, it is a plugin with some description, and people can let comments about, okay, it works, that's great, or I have a problem, or where is some additional information. So that's great to get some feedback. I'm a bit in advance. Yes. if you want to create an application from Gephi and use it, for instance, on a server with tons of RAMs and export visuals, it's possible by using the Gephi toolkit. I mean, you will just have to download the jar already made for you, and you can find some example here in the toolkit portal. And we start to have some real-world applications, like for instance the Truthy platform to automatically detect misinformation. They create the images for each meme of information in real time based on Gephi. And they also compute some statistics. They modified Gephi for that. Also for Bio4G, to visualize network in real time, they use a Gephi toolkit in background. And here you will also find many tutorials on how to use the Gephi toolkit, from manipulating a graph, generating complex networks, computing metric, applying a filter, export the graph in PDF, for instance, reuse it in a Java applet, and so here you will get real code that you can copy paste and modify it for your need. Once you start to get it, it's really straightforward. Okay. I'm a bit in advance, so if you want to have some specific question or you want to dig inside some particular question, just ask me. I remember yesterday somebody asked me why we mostly use 2 dimensions in Gephi, why not 3 dimensions? We see a talk yesterday with an application that they use 3D for artificial neural networks. What is the trade-off? What is the advantages and the problems by using 3D instead of 2D? Do you have some ideas about that? Well, why did you choose to render the visualization in 3 dimensions? Yeah, but visually, I mean, our screen is in 2 dimensions, so they cross anyway. But I remember that something you always rotated the visual. Yeah. Yes, but they cross because your brain understands the 3D because you are manipulating it. The main advantage by using 3D is a different point of view, of course. It is good when you manipulate, but it is also a limitation. You have to rotate to manipulate the object in 3D to understand it, because some elements may hide other elements. So you have more freedom because you use a 3rd dimension on space, but you can't also. It's more difficult if you just want to have an image, and well, it's really a trade-off what you want to do. So if you want to have 3 dimensions in Gephi, it's possible. I will show you now. So it's part of our advanced options in Gephi because we designed Gephi for 2 dimensions use mostly, but behind it we have a 3D engine. So let it free. So on these options, I can select different shapes. I will select another network. It's too bad, this one. Okay, this one, for instance. I could use rectangles. I could use also 3D spheres. And by using the central button of the mouse, also again the mouse, I can start to change the view. I still can't rotate because we have not coded the feature, but there are some people who also use Gephi, and they made some the features to have it in 3D, in full 3D. So it's still possible, but well, depends. Some people really like to have the 3D. Depends if it helps or not, but it's possible. Maybe a couple of words about filters. I mean, we have only scratched the surface by using filters. It is made to combine filters. I mean, for instance, I want to get only I can have only these 2 partitions. Okay, but I may also combine it with another filter. So for instance, here, what I do is that I will filter the network by degree range, and after that, I will filter by partition. So the partition filter will take as input the output of the degree range. And so I can have only, for instance, the core elements of these 2 partitions. Or I can try to see if they still connect if I remove the top connected nodes. Well, seems the case. I will change the size to better see. I may want also to focus only on one node and the neighborhood of a node, what we called ego-centered networks. So here we'll create another query where, well, I want to have the node IDs. So for instance, if I want only Java node ID 27. It's not directly straightforward, but it will work. And I filter. So here I have only the direct connections. around Javert and the connections between his direct connections. I could just also remove him from the network to see the neighborhood. And I can extend it to the context of contacts. Here I have almost the full network. And at distance 3, I get the full network. So you can have many different filters. It's not only related to union and intersections of nodes. It can be somehow more complicated. So for instance, to get the neighborhood of a partition, it's possible. You can combine filters also with intersection. You made the opposite, or filter only on edges. You could also filter the edges, remove the self loops, filter on the edge weight, so to have only the top edges, the backbone of the network. So just try something, try to see what are the filters available in the filters library. Well, so do you have any question about Gephi? Something? Okay. So, well, I will finish now. I really want to thank you for attending this course and ask me so many questions. I mean, I'm really impressed because I've done a computer science studies, and I moved slowly to different areas. So I see that especially more about sociology or a bit of design. So I'm still really impressed. Everybody here is better than me in computer science. I can assure you. But you will find that you can really make the difference if you are just interested in another field, what people do, what are the needs in very different areas, something that you just love, you just want to help to improve. We are in times that every computer science is everywhere, and it is really a matter of imagination what really can do, and to identify the right thing to do. So if you find also your way to help people and receive positive feedback, okay, oh, it's useful, it starts to be really, really wonderful, and I hope also that you will find some people who are so amazed about your work that you will get boosted about what you do, and you want to continue. For me, it's a real pleasure to contribute to Gephi and to try to see, okay, you can do this, you can start to maybe see the world in a different way, maybe it can help. So, well, I hope it is helpful for you. Really, thank you.